Hi guys, today we're going to solve equations where we have variables on both sides of the equal sign. We're going to solve them just like we do our two-step equations. We need to simplify each side of the equal sign first using distribution, and maybe we multiply to get rid of fractions and then combine like terms. And then once we have each side simplified, we will move things across the equal sign using addition and subtraction. And we want to make sure we get variables on one side of the equal sign and constants on the other side. Now, we have 6k minus 3 equals 2k plus 13. It does not matter whether we move the variable first or the constant first, but I am going to start with my variable. Here we go. I lost my cursor there for a second. 2k minus 2k. Okay, so this 2k minus 2k, that's going to cancel out. It's going to zero out, and I'm going to be left with just a 4k on this side. Okay, and then I'm left with, I also have that minus 3 equals 13. The next thing I'm going to do is subtract or add my 3 to both sides. Again, these two are going to zero out and cancel. I'm going to be left with 16 on this side. And I'll have a 4k equals 16. And the last thing that we're going to do is divide by 4. So that our final answer comes out to k equals 4. Now, if you remember, we can check these in the calculator. And the way we did this with our solving multi-step equations is on the calculator, go to y equals, and y1, we're going to put our left side, which in this case is 6. We're going to use an x for k, and then minus 3. And y2, we'll put the 2k, in this case x, plus 13. Remember, when we're putting in the calculator will only graph x, y. It will not graph other variables. So whatever the variable is on the paper, when we go to put it in the graphing calculator, we're going to mark it as an x. Okay? And now let's go look at our graph. I can see both equations, but my intersection is going to be way up here. You can kind of see where they're starting to come together. Since my intersection is not visible on my screen, I need to zoom out. So we're going to take the zoom button and number 3 and then hit enter. It'll zoom out so now we could see our intersection. And now we're going to do second, trace, 5, and then we're going to hit enter 3 times. 1, 2, 3. And look down here where it says intersection, our x is 4. Okay, which is what we came up with when we solved it. So good job. All right, let's try. I want you to try number 2, the you do number 2. So pause the video for a moment, and then you work this out and come back and let's see if you got it correct. All right. If you are back from pausing the video, okay, you see I've already got my minus 3t from both sides. So I have 6t plus 7 equals negative 5t now. So now I'm going to take that 7 and subtract it from both sides. And these are going to zero out. This side over here is going to become negative 12. Now on the left, I still have a 6t. So 6t equals negative 12. My equal sign does not look like an equal sign. And all right, there we go. Hopefully, maybe. There's my equal sign. And then the last step is that we're going to divide by 6. So I'm going to have t equals 2. Okay. Again, you could take your calculator and check this. Put this 9t plus 7 into y1, 3t minus 5 into y2, and find their intersection. All right, let's look at number 3. We have 5 plus 2 times k plus 4 equals 5 times k minus 3 plus 10. Okay, so we have to simplify each side before we could start solving. So to simplify, we're going to start by taking care of these parentheses here. And okay, so we're going to take this 2 and distribute it into this first set of parentheses. And this 5 is going to go into this set of parentheses. So I'm going to have 2k plus 8 and 5k minus 15. But I'm still going to bring along this 5 on the left and this plus 10 on the right. Okay. I don't have any fractions I need to worry about. So the next thing I'm going to do is check for any like terms on each side. So on the left side here, I have a 5 and an 8. Those are my like terms there. So this 5 and this 8, I'm going to add those together to get a positive 13. On the right side, I have this negative 15 and this positive 10. I'm going to add those together and get a negative 5. And again, I'm bringing along this 2k that we didn't use and this 5k that we didn't use. Okay. All right. Now we're down to basically just a kind of a 2-step equation. Well, 3-step equation. We need to take this one of the k's and move it to the other side, and then one of the constants and move it to the opposite side. So let's take 5k. I'm partial to moving all the variables to the left, but you can move them to the right as well. It does not matter. Okay. Those are going to cancel out. This right here is going to give me a negative 3k. And then I've got plus 13 equals negative 5. Okay. And then we're going to subtract the 13. Ew. And we end up these 13s canceling out. And we're going to end up with a negative 3k equals negative 18. Okay. And the last thing we're going to do is divide by 3k, by negative 3, sorry. So by negative 3. Technical difficulties, folks. All right. So k is going to equal positive 6. Again, we could check this by putting 5 plus 2 times k plus 4 into y1, and 5 times k minus 3 plus 10 into y2. And then we can check the graph to find the intersection. All right, I want you to work out number 4. And then take a moment once you're done with this video, write out the process that we used for solving problem 3. Like, what did we do on each step? Okay. Let's take a moment to solve number 4. Pause the video, work out number 4, and then come back and we will start the video back up, and I will have the answer going for you. All right, so if you pause the video and now you're coming back to check that you did it correctly, you should have distributed the 7 to get a 7c minus 28. And you've got an 8c plus 1 on the left, and you still have a 2c here on the right that we're bringing down with it. We have a 7c and a negative 2c here that can be combined to give us a 5c. Minus 28 on the right, and on the left we're going to have an 8c plus 1. Now we can subtract 5c from both sides. Those will zero out. We'll have a 3c plus 1 equals negative 28. We'll subtract 1 from both sides. These will zero out. We will have a 3c equals negative 29. Okay. And our last step is to divide. So we're going to divide this. Get c equals negative 29 over 3. Yes, folks, we are going to leave it there. We do not want a decimal on this. Just leave it as that improper fraction. Okay, again, with algebra, we're going to leave it as an improper fraction because later when we start talking about linear functions and linear equations, we use those improper fractions to actually graph our linear function. So we're just going to leave it as an improper fraction for now. Okay? All right, let's flip the page, and the next problem that we're going to look at has some fractions in there. Oh my goodness. Okay, so the way we're going to get rid of these fractions is to multiply by a common multiple, preferably the least common multiple. So if I look at 5 and 15, my least common multiple is 15. So we're going to take both sides of this equation and multiply by 15. Okay? Now when I take 15 divided by 5, I get 3. And then when I multiply by 2, I get 6. Okay? Your graphing calculator, you can put the fraction in there so you can actually multiply 5 times 2 over, or 15 times 2 over 5 if you need to, so that you can actually get your answer if you have a hard time multiplying with fractions. Okay? And then we have that 15 times negative 9 that we have to multiply. And 15 times negative 9 is negative 135. We've got 15 here that we're going to multiply to that number, to that 9. That is a positive 135. And 15 divided by 15 is 1. So then that's going to leave us with a negative 3n. Okay? All right, now I don't have any like terms I need to combine. We could just start moving things across. So plus 3n, plus 3n. That zeroes out, and we have 3n. Okay? minus 135 equals 135. And let me put the rest of my 3 back there. All right. And then we're going to take this negative 135. Now we're going to add 135 to both sides. Okay, these are going to zero out. So now we'll have 3n equals 270. And our last step is to divide by 3. So we're going to end up with n equals 90. Okay. All right. Number 6, have a go at that one. And when you come back, pause the video. When you come back, you can see it worked out and make sure you did it correctly. Okay. All right. So on number 6, we multiplied by 2 to get rid of the fractions. Then we added p to both sides, and then added 20 to both sides, and that got variable on one side and coefficient on the other, or excuse me, constant on the other side. And then we divided by 4, and to get our final answer of 9 equals p. Remember, all of these equations that we're working out, you can check in your calculator using the y1 and y2 features. Okay. Now, let's look at 7 and 8. 7 and 8 are kind of special equations for us. Okay. So I want to make sure I have plenty of room so I can write some things here for you. Okay. We're going to start them out the same way. We're going to solve by simplifying each side and then moving our variable to one side and our constant to the other. So, and I'm not going to worry about changing colors here. I'm just going to leave it all in one color for right now. Okay. So I'm going to distribute this 1/2. I have 2c minus 3 minus 2. On this side, I have 2c minus 4. That is a 4, folks. I promise. All right, so minus 4. Right here, I've got these like terms that I'm going to combine. So I have 2c minus 4 equals 2c minus 5. Okay. Now, when I subtract my 2c from one side to move it to the other side, here, these cancel out. But over here, I also have a 2c minus 2c, so those zero out as well. I can't just put a c down. If I put a c down, that means I have one left. Okay, but both of my variables, both of my c's zeroed out. So all I have left is negative 4 equals negative 5. Okay. We know that negative 4 does not equal negative 5. We're looking at basic algebra here. Okay? So because -4 does not equal -5, this is a false statement. Whenever we have a variable that cancels completely out, and there's no more variable in the equation, and we're left with a false statement like this, this means that we have no solutions. Okay? So no solutions because our variable is gone, both of them zeroed out, and we were left with a statement that was not true. Now, we can either write out no solutions, or we can write out the symbol for it, which is this circle with a line through it called the null set. Okay? So just to make sure we have a formal definition for this, no solution if the variable cancels and the remaining statement is false. Okay? All right. Let's look at number 8. I might change colors just so things don't overlap. All right. Again, we're going to simplify it just like we would any other equation. Now, I've got this negative right here. This is a -1. Okay? There's not a number there. It's understood to be a 1. Okay? So this whole -1 gets distributed into that parentheses. So I'm going to have 5d plus 15 equals 6d plus 12 minus d plus 3. Okay? Now really all this -1 did right here was just change both of these signs. Okay? It didn't change the values, just change their signs. Now I have like terms on the right side here. I have 6d and -1d that I can combine. That'll give me a 5d. I have this plus 12 and this plus 3 that I can combine. That's going to give me a plus 15. And on the left side, I have 5d plus 15. Okay. I know you probably are already seeing something here, and yes, we can look at this in just a moment, but let's go ahead and subtract our 5d. Okay. I'm sure you're noticing that at this point, both sides look to be the same. Okay. So we're going to subtract our 5d from both sides. Again, both of our variables cancel out, and we're left with 15 equals 15. This is a true statement. Okay? Because this is a true statement, this is all real solutions. Okay? All real solutions. That means that it does not matter what value we put in for D, we will always have a true statement. Okay? So, you might also see it written as infinite solutions. Okay? Now, the symbol for all real solutions or infinite solutions is this kind of funky, fancy looking R. Okay? It's an R with an extra leg on it. Okay? So we have all real solutions. Let me fix this. We have all real solutions if our variable cancels and the remaining statement is true. Okay. Now I'm at the top of the notes here. We did skip that summary statement, so let's go back to that for a moment. On this summary statement, okay, we will simplify and combine like terms on each side of the equation before moving variables to one side of the equation. Okay. Okay. Once we move those variables to one side and constants to the other, then we can do the last step of dividing our coefficients so we can actually solve. Okay. All right, guys, let me pull this up so you can see both pages at once. All right. I will post these pages on my class website. So if you need to look at them as a static, you can. Okay. If you need to rewatch this video, please do so. Okay. And I will have a link to the video on my class website. See you guys later and have a good day.